So this is 2.5b as in boy, the second video on addition and subtraction with fractions. So let's continue along with this. Let's look at example 6. We have 7 over 15, and we're going to subtract 3 over 10. Okay, so we take our 15 like we did before, break it into its primes. 10, we're going to break it into its primes. We're going to circle the ones that occur the most. 3 occurs most here, it doesn't occur with the 10. The 5 occurs the same on both the 15 and the 10, so it doesn't matter which one you grab, just grab one and cross out the other. And 2 occurs with the 10 but not with the 15, so the most times it occurs is one time with the 2. So we're going to get a 15 up here and a 2 here, multiply. So my common denominator is 30. So we are going to change this to have a common denominator of 30. So the question is again, what did we do to get this from a 15 to a 30? Well, we multiplied it by 2. So we're going to multiply the top by 2. Then we look at my other fraction right here. What did I do to go from 10 to 30? Well, I had to multiply it by 3. If I multiply the bottom by 3 to get it to be a 30, I have to multiply the top by 3. And that gives me a 9. And since my denominators are 30, my answer is going to have a denominator of 30. And I'm going to subtract my 14 minus 9 and get 5. So I have 5 over 30. But now I have to look and see if I can reduce that. And when I reduce that, I just have to look and see if there is a number that will go into both 30 and 5 evenly. And in this case, 5 goes into 5 once, and 5 goes into 30 6 times. So 1/6 is 5 over 30 reduced. Now if you can't find a number, if there doesn't exist a number that goes into both the top number and the bottom number evenly, then it's already reduced and you can't do what we just did, changing from 5 over 30 to 1 over 6. Alright, so let's jump to some that are a little bit trickier, more challenging. Let's look at example 8. Okay, so we have 3 numbers we're going to do. So let's look at this. It's going to be 3 times 2. 8 is going to be 2 times 2 times 2. And 4 is going to be 2 times 2. So we're going to follow the same procedure. We're going to look at my numbers here and look and say, alright, there's a 3 there. It occurs one time. Is there somewhere else that occurs more often? Nope. So we want that 3. Now let's look at the 2. 2 occurs once here, it occurs 3 times here, and it occurs twice here. So we're interested in the one in the row where it occurs the most, which is that one there. It occurs 3 times there. So we cross out the rest of them. We don't want those. So we multiply everything that's circled. 3 times 2 times 2 times 2, and that gives me 3 times 2 is 6, times 2 is 12, times 2 is 24. So my common denominator for these fractions is 24. So I'm going to put a 24 there, and a 24 there instead of the 8, and a 24 there instead of the 4. Now I need to go back and look and say, okay, what did I do to get from 6 to 24? I multiplied the 6 by, let's do this in red here, I multiplied the 6 by 4. So I'm going to multiply this 1 by a 4. Okay, now what did I do to go from 8 to 24? Well, I multiplied my 8 times 3, so therefore I multiply my numerator, 1 times 3. Now what did I do to go from 4 to 24? I multiplied by 6, so I multiply my top number by 6. So my answer is going to have a 24 in the denominator. I'm going to add my numbers here, which would be 4 and 3 is 7. 7 plus 6 is 13. And since 13 is a prime number, nothing goes into it. That also goes into 24. So 13 over 24 ends up being my finished answer then. So this is example 11, and we're going to add 3 different fractions, but some of them are negatives and some of them are positives. So let's go ahead and ignore the signs, and let's just try to find common denominators first. So we have a 10, a 5, and a 20. So my 10 is 2 times 5. My 5 is already prime, it doesn't break down, so we'll leave it a 5. And my 20 breaks down to 2 times 2 is 4 times 5. Okay, so now what I'm doing is I'm looking to see which of these rows has the most 5s. Well, they all have 1 5, so we'll just circle 1 and get rid of the other ones. And now we're going to look and see, okay, this one has a 2, this one doesn't have any 2s, and this one has 2 2s. So I'm going to take both of these 2's and I'm going to get rid of the one that doesn't occur as often. I'm going to multiply everything that's circled there, and in this case it's a 5 times 2 times 2. 5 times 2 is 10, times 2 is 20. So my 10 is going to change to a 20. My 5 is going to change to a 20. Notice I'm leaving my numerators alone. I've got the sign up there, but I don't have any numerator there, and that's going to be a 20. Alright, so now we look and say, what did we do to go from 10 to 20? Well, we multiplied 10 times 2, so therefore we multiply the 1 times 2. And how did we go from a 5 to a 20? Well, we multiplied 5 times 4, so therefore we have to multiply 4 times 4. In here we have a 20 and we have a 20 there, so nothing changed. So that means the number on the top does not change here. Okay, so now there we have in red our problem now that is with common denominators, and we can just combine. So we know on the bottom, well, let's just take these one piece at a time. Let's take these two first and combine those. Our bottom is going to be a 20. Our denominators are the same. And this says take 2 plus negative 16. So remember, when you add opposite signs, a positive 2 and a negative 16, you take the difference between the two numbers. Difference between 16 and 2 is 14. And you put the sign of the largest number on your answer. Okay, so now we have that plus negative 3 over 20. And our denominators are the same, so we can continue on. Alright, let's look and see what we've got here. We said our denominators will always be the same as the two problems that we're adding together, or the two fractions that we're adding together. So let's look at our numerators. Two numbers, same sign. When the signs are the same, you just add the numbers. 14 plus 3 is 17, and you put the sign on the number. And again, it doesn't matter if that negative is on the 17, if it's on the 20, or we stick it out here next to the division symbol there. It doesn't really matter where it goes. This last example, which is example 13, is they're trying to get you to learn how to write fractions from smallest to largest or from largest to smallest. So what they did is they gave us a fraction 5 over 8, 5 over 16, 3 over 4, and 1/2. And they want you to write those in order from smallest to largest. Now, you can't do that unless, first of all, you get all of the least common denominators. So you need to find the smallest number that both 8, 16, 4, and 2 will go into. So that's where we go back to our 2 times 2 times 2, 2 times 2 times 2 times 2, 2 times 2, and 2. Alright, so now we're going to look and see our 2's occur 3 times here, 4 times here, twice here, and once here. So the place it occurs the most is right there, and the rest of them can go away. So this multiplied together is 16, so that's your least common denominator. So a 16 there, you're going to have a 16 there, 16 there, and a 16 there. Okay, so now the question goes, how did we go from 8 to 16? Well, we multiplied 8 times 2 to get 16, so now we do 5 times 2, and that gives us our number on top. We have a 16 there and a 16 there. It didn't change, so therefore our top number doesn't change. Then we went from a 4 to a 16. Well, we multiplied 4 times 4 to get 16, so we multiply 3 times 4 to get the top number. Now last, we look at the 2 and how it changed to a 16. We multiplied 2 times 8 to get 16, so we multiply 1 times 8, and that gives us 8. So there are each of our fractions now with common denominators. Now it's real easy to put them in order from smallest to largest, because you just look at the numerators and start with the smallest and go to the next one. The smallest numerator is a 1. The next smallest is a 5. The next smallest is an 8. The next smallest is a 10. And then the next one is there. So there's the order from smallest to largest: 5/16, 8/16, 10/16, and 12/16. And what I would do then is, since that's the order, I would just come over here then and say, okay, so 5/16 is the smallest because it corresponds here, and 1/2 is the next one, 5/8 is the next one, and 3/4 is the next one. And we used this in order to make that determination. So that's it for 2.5.